Hello everyone, we are back to the last section of chapter 3, 3.8. In this particular example, we're going to be talking about independent events and dependent events. Basically, what we're talking about is a pair of events that may depend on each other or not. For example, flipping a coin on one hand and rolling a die on the other, they have nothing in common and they will proceed and get a probability independently. However, if you're looking at a deck of cards and you draw a card and do not put it back in the deck, then it's going to make one less to pick from if you are going to pick a second card. So whatever happens on the second event depends on what happened in the first event. And that's what we mean by independent, they don't affect each other, versus dependent, they affect each other. So here are some examples to help you along. In this particular one, you see where I roll a 3 on a 6-sided die and I flip a coin. Rolling a 3 is 1/6, getting a hedge is 1/2. You multiply them and you get 1/12 is a possibility or probability of these two events occurring. If you look at this example here, we have a bag of 8 marbles, 8 green, 6 orange, 3 white, 7 yellow. That's a total of 24 marbles. Now, if you think about the probability, if I wanted a white one, then we know it's going to be 3 out of 24. But look what happens next. If I drew one, I have one less the next time around. There could be 8, but I'm picking 8 out of 23. So the second event depends on whatever happened in the first event. And this is what we call without replacement. And here you have this pair of events, you multiply them, and you can see that I can reduce this one by 1, get a 3 there, 3 over 3, they cancel again, and you get 1 over 23. All I did was reduce the fractions there. Now, this is asking simply to classify the events. Flipping a coin and rolling a die, they do not affect each other. We call these independent. Over here, selecting a card from a deck and then selecting a second card from the deck. Well, in this case, it all depends on what I drew the first card and if I put it back or not. So there's some complicated things to look at here. And if I'm not careful, I may be looking at independent or dependent events. But for the most part, one card depends on the other. So we write dependent events. Let's come over here. If I were to add up all these marbles, 5, 6, 5, 9, I'm going to get, let's see now, 25. Yes, 25 marbles. It says now, I want the probability of selecting a green marble. I'm going to write prob of green. And then a blue one, prob of blue. Now the green one, as you can see here, there are 5 greens out of 25. Now, I don't put it back, so there is one less marble to pick from the next time around, and I am looking at a blue one, and a blue one would have, as you could see, 9. Now, you could multiply these fractions and get a very large numerator and denominator, but this is why you want to reduce before you actually write the answer. In this case, I can do 5 times 1 and 5 times 5, and I cross out the 5s, I get 1/5. Here I can do the 3s, 3 times 3 and 3 times 8. I cross out the 3s and I can do 3/8. And this is much easier to work with because now 1 times 3 is 3, 5 times 8 is 40. And so it's a good thing that I knew my fraction multiplication and reduction from arithmetic because it made my calculation much easier to do. In this particular formula, it assumes that the events are independent, and this is why they write it like this. The probability of both happening is the same as the probability of the first one times the second because they do not affect each other. So let's put the numbers in. It says the probability of A would go here, the probability of B would go there. Then let's see what this would be. I would say prob of event A and B, B is equal to prob of A times prob of B. And then we put the numbers in. This is 2/5, and this is 1/2. And as you can see, we can really reduce here. 2/10 is going to be the same thing as 1/5. These are just general formulas of independent events. A 6-sided die is rolled twice. Once, twice. What is the probability of getting an even number first? Okay, prob of even, and then the number 3, prob of 3. Well, even, there's 2, 4, and 6. So that's going to be 3 out of 6. And means to multiply. Now there is only 1 3 in the whole die, so that's 1 out of 6. If I were to multiply these two, I can reduce this down to 1/2 times 1/6 will be 1/12. All right. A coin is flipped once and a die is rolled twice. Coin once, die twice. What is the probability of getting a tails? I'm going to write prob of a tails. The number 2, well, I want to get prob of the 2. And then an odd number, prob of an odd number. Now, tails would be 1 out of 2 because we either have heads or we have tails. The probability of a 2 on a die would be 1 number out of the 6. And then the third one, the odd numbers are 1, 3, and 5. That's 3 out of 6. They are independent of each other. And so this is what we write. I can reduce this down to 1/2 so that it's 1/2 times 1/6 times 1/2, and you get 1 out of 24. Very slim possibilities of that happening. Last thing about probability for chapter 3. There are 26 letter tiles in a bag, A through Z. What is the probability of selecting 3 different vowels, A, E, I, O, U, or Y, without replacement? Now remember, this means you don't put the tile back. My first one would be 1, 2, 3, 4, 5, 6 possible vowels out of 26 letters. Now the next one is going to be 25 because I don't put the tile back. I take one out and I have 1, 2, 3, 4, 5 possible vowels. I take it out and I have 24 tiles left this time. And I take another one of the vowels out, 1, 2, 3, 4. So you see you have 3 very large looking fractions. I'm going to try and reduce them before I multiply them. I can reduce this by 2 to get 3/13. I can reduce this by 5 to get 1 out of 5. And I can reduce this by 4 to get 1 out of 6. Now I can do it again. You see the 3 and the 6? I'm going to cross this out, put in a 2 down here. 1 times 1 times 1 is 1. 13 times 5 is going to be 65. And times 2 is going to be 130. And so I use my arithmetic to make this fraction calculation much smaller and manageable. Once again, this is probability of independent and dependent events. And so this is a way to handle that.